Hello Math 2 students, and welcome to your 4.1 Ed Puzzle. So, we touched on this last semester, but let's take a look at the different kinds of linear equations we need to be familiar with. So we have slope-intercept form, which is y equals mx plus b. M is your slope. This is a little too thick. M is your slope, and B is your y-intercept. All right, and then the other form of a linear equation we need to be familiar with is point-slope form, where we have y equals m times x minus x1 plus y1. Another common format of this is y minus y1 equals m times x minus x1. These are the exact same thing. The only difference here is that the y1 is moved over. All right. So what you need to do is you need to know when to use each of these equations. So let's go ahead and take a look at number 1. It says, given a line with a slope of 1/2 passing through the point 4/3, write an equation of a line in point, slope, and slope-intercept form. So what you're going to want to do here is, they did ask for it in point-slope form, but really, you need to decide, well, what did they give me here? They gave me a slope, and they gave me a point. So what do I want to start out with here? Well, I want to start out with point-slope form. So let's go ahead, we'll use the first one. It doesn't matter which one you use, honestly, but let's go ahead, we'll use the first version here. So we've got y equals, oops. And then for m, we're going to plug in our slope. So we're going to do y equals 1/2 times x minus, and then we're going to do x1. Your x1 is going to be the x coordinate of your point. So in this case, that's going to be 4. And then we've got plus y1, which is going to be the y coordinate of your point. So we're going to say plus 3. So this is your point slope form. And we could stop here for point slope form. All right, but then they also ask for slope-intercept form. And kind of an easy way to think about getting it into slope-intercept form is essentially you need to distribute the slope and then combine like terms. So I just copy-pasted what we started with. So we need to distribute the slope, which gives us 1/2 x minus 2. And then we still got that plus 3 on the outside. So we distributed, now we combine like terms. Notice the slope was only distributed to the x term and the -4. Since the plus 3 was on the outside of the parentheses, we do not distribute it to that. So our final answer here should be y equals 1/2 x plus 1. And this is our slope-intercept form. All right. Next, it says write the equation of the line on the graph in point-slope and slope-intercept form. So, first thing we need to do is we need to come up with the slope. So, there's 2 ways to do this. First, I'm going to show you how to do it from the coordinates, and then I'll show you how to do it just by counting on the graph. So let's go ahead. Let's come up with 2 points. This first one here is going to be 0, 3. The second one is going to be 2, 0. All right. And what I'm going to do is I'm going to label this x1, y1, and x2, y2. Then we're going to plug that into the slope formula. If you don't remember, I would definitely write this down. The slope formula, I don't know why that did that, is y2 minus y1 all over x2 minus x1. So I labeled these accordingly, and now I just got to plug them into my formula. So I'm going to do my y2, which is 0, minus my y1, which is 3, all over my x2, which is 2, minus my x1, which is 0. One thing I do recommend is not going to your calculator right away. I recommend just calculating the top and calculating the bottom and then simplifying. Sometimes if you try to plug all this in at once, you will make calculator errors if you don't put parentheses in the right spots. So first, let's calculate the top. 0 minus 3 gives us a -3. 2 minus 0 gives us a +2. So our slope here is going to be -3/2. All right. So another way you could have calculated this is calculating your change in y over your change in x, or you could think of it as rise over run. And in this case, we could go up 1, 2, 3. So that's our rise. And then our run is 2 back, which would give us a -2. That is another way you could calculate the slope. But unfortunately, I think sometimes that confuses people. And it cannot be used in all situations, especially when the axes change. And that happens a lot on standardized tests. So I would be, you know, if you had to pick one method to really master and be good at, I would recommend this method here. So now let's go ahead. We've got our slope. Now we have to figure out, okay, well, we've got our slope. What do we need? Well, we can use point slope form, which again, we'll use this version of it. All right. And what we need to do is we need to plug in here for slope, which we already found. And then we need to plug in a point. It really does not matter which one of these points you pick. I'll go ahead, I'll just use what's already labeled x1, y1. You could, though, use this point if you preferred. It does not matter. So let's go ahead and plug that in. We'll do y equals, and then our slope, which is -3/2, times, and now we've got x minus, and we're going to do our x1 term, which is 0, and our y1 term, which is 3. So we'll do +3. So this answers the point slope. All right, but they also want it in slope intercept. So let's go ahead and get it in slope intercept. We're going to go ahead and distribute. Then you end up with +0, essentially. +3, combine like terms. And that would be your slope intercept form. All right, perfect. Next, it says, write the equation of a line that passes through 2, 5 and 2, -3. All right, so let's go ahead. First thing I want to do here is find the slope. So if you recall, to find the slope, we're going to say we're going to use y2 minus y1 all over x2 minus x1. Let's label these. We'll say x1, y1, x2, y2. So we'll go ahead and plug them in. We get -3 minus 5 all over 2 minus 2. All right. So what ends up happening here is we get -8 divided by 0. This is a problem. We can't divide by 0 in math. Whenever you end up having a 0 on the bottom, that's going to be an undefined slope. Undefined slopes are, these are lines that go up and down like that. They're always going to be x equals. So to write the equation of this line, it's actually pretty easy. Since the slope is undefined, you just look at the x term that both of them share. It's going to be x equals 2. All right. And then for number 4, we're going to see we're going to run into a similar but different problem. We got y2 minus y1 all over x2 minus x1. Let's label them. We get x1, y1, x2, y2. So let's do 5 minus 5 all over -4 minus 2. Which is going to give us 0 over -6. Now here the 0 is on top. And this you could actually plug into your calculator. It's just going to give you a slope of 0. All right. So when this happens, you're going to have a y equals. And that's because it goes side to side like that. That's a slope of 0. And you're just going to do y equals whatever y value they share. So y equals 5. All right. So that's just kind of a review of linear functions. So let's go ahead. It says create a story to match below. So we don't necessarily need to create a story, but let's kind of look at this graph. All right. We have to describe what's happening here. Okay. So we could even think, maybe it's someone walking, this could be, maybe we'll just say this is distance and this is time. All right, so the person starts walking, and then they stop walking for a little bit, and then they continue to walk a little bit more, and then they start walking backwards. All right, that would be an example, a story that would kind of fit this graph. all right? So it says, if you were to write a function to match each part of your story, how many would you write? So if we look, there's actually going to be 4 separate parts to this, okay? So we'll make this the purple part. We'll make this the green part. Oops, we can make this the blue part. And this part, the red part. You can see that there's actually 4 different functions going on here. So you would say 4 functions. All right. And it says identify and write the function and corresponding domain. All right. So what they're talking about is, let's go ahead. We'll do this first one in purple here. They want us to write the equation of this first function. So what you need to do for that is you need to first come up with the x values that this holds true for. And one thing I will point out is we actually don't know which function kind of takes over at these crossover points. So we'll just kind of guess on those. Since it's a filled in circle, we don't know if this since it meets both the functions meet up at that point. Without that piece of information, we actually don't know if it should be opened or closed there, essentially. So let's go ahead. Let's see, we've got our subfunction. We need to come up with the equation of this line. So we could look. This is definitely going to be a slope of 1. We'll assume that these are all 1, 2, 3. So the slope here is going to be 1. It's up 1 over 1, up 1 over 1. So our m is 1, and then our b actually is 0. This one's kind of nice and easy. So all we need to do is plug into y equals mx plus b. So it's just going to be 1x or just x. And then your y-intercept is 0. So you would say like plus 0, but you don't write that. So it's just x. And the domain here is going to be, we'll say x is going to be greater than or equal to 0 because it starts as 0. And we'll say less than 5. All right. Now we have to come up with the equation of our green line. Now, if we look here, the green line is just a horizontal line. When you have a horizontal line like that, it's just going to be y equals whatever y value is your output. And in this case, it's a 5. So our subfunction is just 5. Whenever you have a horizontal line, you just look at the y value, the output. All right. Then for the domain, all right, since we did an open interval at 5, we'll do a closed interval at 5 for this function. And we'll say 5x, and then we can do an open there for 10. How did I come up with these values? Well, you got to look at the x values that this function kind of holds true for, and it goes from 5 to 10. All right. Then we'll go ahead, let's do our blue graph. Now this one is going to be a little bit trickier. We have 2 points, so we can come up with the equation of a line. So let's go ahead. We've got 10, 5, and 15, 15. So let's go ahead. We will now calculate the slope. We'll say x1, y1, x2, y2, and we're going to plug that into our slope formula. So we'll say 15 minus 5 all over 15 minus 10. We end up with 10 over 5, which gives us 2. All right, so we've got a slope of 2. And of course, we can just pick one of these points to plug into our point slope form, which is y equals m times x minus x1 plus y1. So we get y equals 2 times x minus 10 plus 5. Distribute, and we end up with y equals 2x minus 20 plus 5, which would give us y equals 2x minus 15. All right, so we're going to say 2x minus 15 is our equation, and the domain of that will be 10 to 15. All right, now we've got our last equation there, so we are running out of space. I'll kind of do it down here, and that one is in red. So, of course, we need to go ahead and calculate the slope. On I'm going to do the kind where you just calculate rise over run. So we go up 1 and back 1, which is going to give us a slope of -1, right? Because it would be, we go up 1, our rise is 1, and our run is -1, so our slope would be -1. And then we can just pick a point. We'll do 15, 15, all right? So we got our slope, we've got our point. We're going to plug it into our point slope form. And we get y equals -1 times x minus 15 plus 15, which is going to give us y equals -x plus 15 plus 15, which gives us y equals -x plus 30. So we're going to have -x plus 30 as our equation. And the domain, this starts off at 15 and it goes to 16, 17, 18, 19, 20. So we're going to say 15 to 20. All right. The function you created above is called a piecewise function. A piecewise defined function is a function defined by more than one subfunction or piece of function, each section only existing in a certain interval of the function's domain. So basically it just means that different functions hold true for different parts of the domain. All right. And then we've got our last part here. It says find f of 12. So let's go ahead. If we look at f of 12, we know that we have to use this function here. How do I know that? Well, our input is 12, and 12 is going to fall in between 10 and 15. So we're going to use the function 2x, was it minus 15? Yes, 2x minus 15. So we're going to say 2 times 12 minus 15, which gives us 24, minus 15, which is going to give us 9. So we could say f of 12 equals 9. All right. So which subfunction do you use to algebraically find the value of 12? Well, we kind of already answered that. That was the 2x minus 15. All right. So next it says we want to find f of 7. So we got to go up here. We need to use this function here to find f of 7. All right. How do I know that? Because 7 falls in between 5 and 10. All right. And this is actually nice and easy. Whenever your function is just a number, your output is just that number. All right. Now, this one tends to throw people off a lot. All right. It says f of x equals 3. What is the value of x? So what is x when f of x equals 3? And what they're asking you there is, okay, well, when your y value is 3, what is your input? When your output's 3, what's your input? In this case, we could just look at the graph. It makes our life a little bit easier. Our input is 3 when our output is 3. So it'd be that. So now let's look for 13. What is x when f of x equals 13? So if we look at 13, there's actually going to be 2 values. All right, that's going to be at 11, 12, 13, 14, and 17. So we got 2 values there. And then f of 15, so if we look, 15, we're going to use this last function here. Why? Because 15 is kind of a breakoff point, and I put the equal sign with this last function. So we're going to use this last function, negative x plus 30. So we'll say negative 15 plus 30, which is going to give us a 15 out. All right. We could also look at the graph for that if we wanted, right? 15, our output is 15.